All right, everybody enjoys cat and dog drawings, so let's generate some cats and update that. There was a little cat there, and save that. And generate a dog here and update that picture. There we go, we got a pup. That looks like a lab. Save that. Hello and welcome to the Dall-E AI art room. I'm here with my character, Manny Bob Ross. This is made with Http GPT version 1.52. Now, I made an introductory video that shows you how to install the plugin, so I won't be going over that in detail in this video. This video is all about using GPT and blueprints. And now I have this little NFT gallery here, and we can generate images, update them, and then save them. And the name on the wall is the name of the artist. And so when we go over and we generate an image here, I pull up my Painter lead tab, generate, we have a delay, and then I update the image, and that's been communicating with Dall-E. Now I'm going to save that, and we're going to reset to the beginning here. If you're curious, the plugin is here on the marketplace. It is for free, and it is by Lucas ISO here. Go over and support his GitHub, and I have that in here. There's a link to his GitHub. I'll leave that in the description of the video. I'm inside of the GPT blueprint that I built, and the nodes that I use to get access to this are the Dall-E request image with custom options and the generate image. And this is created by Lucas ISO, Lucas Villaboas, and we can right click here and scroll down in the blueprint under the categories HTTP GPT. We have our chat options, our image options, and our settings. Now, because the image one is actually easier to set up than the chat one, I'm going to go over the image one first, and then I will be going over the chat one that I've made as well. And this will hopefully give you enough insight that you could potentially even just build the chat one on your own. Now, here's the setup that I'm utilizing here. And this is just for demonstration. You can have this however you like. I personally wanted to have it so that we have an interaction sphere here. That's the child actor. That is going to have the Bob Ross character pull up his paint palette. Okay. And then we have our frame. And the frame is where the magic is happening on the material. I made this simple master material that I called MGPT, and I have a texture piped into the emissive, and then I have this little setup here, which is our texture coordinates getting multiplied by two scalar parameters that are appended to create an XY or a UV vector. So this is just to manipulate our texture size of the image. From here, I've made a material instance, and this instance is using a new render target 2D texture. That's really the key to all this, is we're creating render targets that we're going to be using to represent as the intermediary before we save them. We communicate with Dall-E and we give the information and we put it onto a render target. And then we're saving the information from the render target as either a JPEG or a PNG. The reason it took me longer than I thought to get a solution to this is I was using the same render target for each frame. In order for it to work correctly in our level, we need to have a render target for each instance of the blueprint. That is something that is critical to know. That's why we have 8 RT_01 through 08 is the render target corresponding to each of the frames in the map here. There's 8 frames on the wall. So understanding that when we start the game, the frames are black because our render target has not accepted any information yet. I've broken this down to a generate image, a update image, and a save image so we can go over the 3 functions. As I mentioned, we also have the placard on the wall with the artist name, and that is just for me for testing and so I can make some funny jokes with the prompts. So what's actually going on here is in blue, we have our begin play. In green is when we have our actual functions that I've created. And then this orange is all of our overlap events when we are overlapping the various buttons. These are buttons, and in front of them is a trigger. I'll quickly go over the setup in my components one more time. The child actor, that's something I added for fun. You can ignore that. That just changes the animation blueprint on the third-person character. The frame is where all the magic is happening. And the child actors here, these are just lights that I have in the scene. Then we have our wall plaque with the artist name. This variable I've exposed so that the users can change the artist name. And we have our 3 buttons here: generate, update, and save. Each button has its own text and then its own overlap collision. Starting with begin play, I always like to use a sequence node as it helps me organize my thoughts and also helps me make sure that the engine is executing things the way I want, so I'm not trying to reference a variable before it is been created in memory. Sequence 0 off the execution pin, I'm just going to set the text for the artist placard, and I want to have that as an artist name that I'm going to make public for the user. The next thing I'm going to do is I'm actually going to create a dynamic material, and I'm going to assign that dynamic material to the frame. I know that the frame, when I open it up, has 2 elements in its material slot, element 0 and element 1. Element 0, if I isolate that, is going to just have our render target on it. Therefore, I know I want to use element 0 for my dynamic material instance. I'm going to use the material instance that I had shown you, our base material instance, and this has our default new texture render target 2D, and I've left the naming like that so that I know when I bring this into the world, I need to make a new one. I need to have a new render target associated with each instance of the blueprint. Once I've created that, I'm then right-clicking and promoting this to a variable, and we're calling that our dynamic material image. The next thing I've done is I've created dynamic material instances for all the buttons: the generate button, the update button, and the save button. I've then gone and made each of those its own variable so that I could reference the dynamic material on each button, turning it from green or red. Next, I'm taking those buttons that I've set as variables and I'm setting up the colors on the diffuse parameter. Green means go and red means stop. And the reason I've set this up is because we want to generate an image first, and then we want to wait 1 second to do the communication to Dall-E, get the image, bring it back, and then turn the color of the update button to green. But by default, when we begin, it's going to be red. I also found out I needed to call, generate the image, and update the frame on begin play to then have one stored in memory. Let's go over how to generate the image, the core of this tutorial. When we overlap the generate image box, the first thing we're going to do is call this custom event generate image, and we're going to turn generate image red because we're doing a communication to Dall-E. I'm waiting 1 second. This is a variable that I've been tinkering with. I originally had it at 5 seconds and then kept dialing it down until I could have it as low as possible while still waiting for the updated image. After we've waited our specified time, and this is going to change depending on your internet connection, so you might have to play with this, and we can right click and promote this to a variable and poke the eye of that variable and then make sure that the user can change that on the fly if you'd like. The next thing is we're going to change the update button to green, meaning we are ready to push our changes and update the image. So I would then walk over to overlap on the update image box. That is going to then trigger our custom event update frame, which will then now allow us to save the image. That will turn green, and we're going to reset generate image to turn green. The final button is the save button. And here, in order to avoid excessive saving, I have here do once, custom event, save image. Then we're going to turn generate back to green, update back to red, and save back to red. And if you're saying, well, if we do it once, how do we reset this? I have set up the reset pin on the do once node to be triggered as our second event when we actually walk over the generate image. So it's going to generate the image, then it's going to update our state for the save, allowing us to then save a new image. Let's go over all three custom events: generate image, update image, and save image. It is as simple as right-click, add custom event, your event name, whatever you'd like to call this, Dall-E image, generate image, totally up to you. Pull off here and type in image, and we're going to scroll down until we find the Http GPT category, and we will get our custom image options, request image with custom options. You can also request image with default options and then set up the default options inside of your project settings under the plugins. Now that we have our request image with custom options, we have a prompt that we can put in here, and then we have our image option size. I'm going to remove this, and you'll see by default we have a 256 by 256, and you can go as high as 1024 by 1024. The image option response format is a type B64, which is a binary 64. You can change that to a type URL if you'd like. The number of images it generates at once is set to 1. You could also have this set to be multiple images. When we split the structure of our common options, this will expose where you place your API key and email for your OpenAI account. I've made the question and the prompt a parameter for the user and made it public. And you can see here the prompt is abstract art by default, okay? This is where it requires a little bit of thinking to understand how this is actually working. I'm going to pull off of the response data, and then I'm going to get a copy or a reference. I'm going to get a copy, okay? And from that, this is going to be our response data is actually the same as our image data. If we go back and look at generate image, when you see the node, it could be looking like this. Now I'm going to right click on the response and split this structure. Now I actually want the response data, an array of HTTP GTP image data structures. That's what I'm going to pull off of our copy and connect our copy to our image data. We have our generate image node here. I can pull off here and type in generate image and what's under HTTP image, generate image. And you might not be familiar with this small bottom red square. This is a callback delegate. A callback delegate is only going to give us a call, calling you back. Hey, I got your message. Hey, did you call me? My voicemail says I have a message. So when I check it, I'm gonna call you back after I've gotten that message. Hey, you sent me the message to generate image. Oh, now I'm gonna give you a call back, image to frame. What is image to frame? That's another custom event that I made to put the image on the frame. When we open that up, all it's doing is it's applying the image that we've gotten from our generate image as the prompt image. Now it will look like this when you have it out. We'll pull off of the callback, and this is where you're going to click add event, add custom event. That custom event will have the image data set up inside of it as a texture 2D object reference. This is the key in what we need to send as our information to our render 2D target. And this is actually what took me a long time to figure out. Now that we have our texture 2D image reference from Dall-E, I'm going to create a variable and call that our prompt image, and I'm going to use that in our next event, our custom event, update image. Now, all update image is doing is we're taking the prompt image that we just created from our image data. And then I'm going to assign that, I'm going to set the texture parameter of the dynamic material with the prompt image. Now here's where we have a parameter name called texture. I'm going to go back into our dynamic material, our MI GPT prompt material. This global texture parameter is called texture. I set that to be called texture, and we go into the master, the parent. This parameter name is texture. That's a terrible name. I should call this prompt image. Copy. Save. Now inside of here, we can see that's changed to prompt image. And in my blueprint, I'm going to need to make sure that is no longer texture, but actually prompt image. Once we've taken our image data and applied it to our dynamic material image in the correct parameter, in the correct slot, our prompt image, we're going to then draw that material onto our render target. And I'm going to take the dynamic material and put that onto our texture render target, which is a variable. Again, I had a few roadblocks, one of them being this. I didn't know I needed to have a separate render target for each blueprint instance. And I didn't know that I needed to use a delegate. And that is what the callback is. Both of those things took me a couple weeks to figure out. And like most problems, if you can't find the solution, no, don't go to Google. Go to bed. Go to bed and ask yourself the question, and then maybe during one of your dreams, you might run into yourself who's still working while you're sleeping, and they might give you a hint. Our save image to disk event, we're going to take our texture render target on our material instance, and we're going to export the render target using a file path that we created. You're going to have to go in and make your own file path. Mine is going directly into my content browser under my generated here. Been making a lot of them, oh boy. And then I've set up this format text, and we can actually grab today, just right click, type in today, and then split the structure, and that will give us all these variables. And then I'm actually set up our format to be texture, year, month, day, hour, minute, second. And now I don't need to have a random seed or anything like that in there. We just have the actual time of the day that we made the image. And really not that much to it, all right? We begin play, we set a text, we set a bunch of dynamic material instances. I set a few variables up so that I could change some colors. Okay, we set this logic up. Mainly the logic is around changing colors for the buttons, right? We're generating an image. When we overlap our generate image, then we are updating the image, and then we're saving the image. And I broke it down into these 3 pieces and 3 buttons to try and make it easy and digestible for you. We could have all of this happening in one function at runtime with no user interaction, and we walk into a level and all of the art on all the walls is completely AI generated. We have our 3 custom events: generate image, where we're requesting an image with custom options, getting our response data, we're using that data to generate an image as a callback, a delegate callback. We're creating an image to frame custom event using that information as our prompt image variable, then applying the prompt image variable to our parameter, prompt image parameter inside of our dynamic material, which is then being drawn on to our texture render target. We then can save that drawing by making a name for it, putting it in a file path, and adding it to our export render target node. And one more time now for fun. Here we go. Let's go over to Fun GE, generate image. We've got our palette up. Okay, update. Fun GE. He's a fun guy. He makes a lot of mushrooms. Save image. And let's try the dragoon. I think you can picture what this one's going to be. Generate. Update. Oh, it's a little red dragon. Nice. Save that one. If you notice some jittering, it's because there's a bit of overlap and an unoverlap with the collisions on the blueprint for bringing up his paintbrush and palette. Blue Sai and Red Sue are competing against each other for the coolest abstract art. Blue Sai makes only blue things, and Red Sue, I think you understand, it makes only red things. That does it for this tutorial on using Http GPT inside of Unreal Engine 5. I'm going to continue on making some AI things, and I'm going to break down my actual dialogue GPT bot, which is a little bit more complicated than the Dall-E bot. Hence why I wanted to do this one first. I'll see you in that video coming soon. Thank you so much for coming by, and I hope to see you next time. Bye now.